Alright, in example 12 here, the height above ground h in feet of a toy rocket t seconds after its launch is given by this formula. Okay, so we have ourselves our formula for a rocket to figure out how high it is. When will the rocket be 180 feet above the ground? Okay, well, I put 180 right in there because that's the height. So to solve this, I notice that I see a squared, so it's a quadratic equation. So I'm going to minus a 180 because I want to get everything onto one side. So I use my quadratic formula. This is A, so negative 16 goes in there. B is 120, so 120, 120. C is negative 180, so I plug in everything. It's a negative 120. 120 squared is 14,400. Negative 4 times negative 16 times negative 180 is negative 11,520 over a negative 32. So I end up with negative 120 plus or minus the square root of 2,880 divided by negative 32, which is about 5.427 seconds and 2.027 seconds. Now you're wondering why you get two answers. One, it's quadratic, and two, you got to keep in mind they're both right because when this starts, it's going up. So on its route up, at 2.027 seconds, it reaches a height of 180. Then eventually it's going to peak, come back down, and when it comes back down at about 5.427 seconds, it is crossing that 180 feet mark again. Okay, so that's why it works, and it works twice.
Where's the beef?
Okay, well, I guess I should have just tried to cram that one in, but I couldn't, so sorry, that was basically the only problem left, so this really isn't that long of one at all, but okay, well, if you have any questions or concerns about anything, please let me know. And with the problem like this, what I want you to keep in mind is um, this formula is pretty accurate for most of the time. This is how you develop things in calculus. You'll eventually realize how these formulas are developed by taking such things called derivatives, which you will not get into whatsoever in trig, and you'll only hit on it in pre-calculus. But calculus, pre-calculus, these formulas that I'm giving to you right now without really telling you where they're coming from, they're great, great tools to use in physics and real application problems. Okay, so just something to keep in mind for yourself. So once again, if you have any questions or concerns, please let me know. And hopefully the examples in 1.3 on quadratics will help.